Zippity-doo-dah, zippity-day. My, oh my, what a wonderful Daily Solutions podcast. Plenty of sunshine coming my way. My, oh my, what a wonderful Daily Solutions podcast. All right, welcome, everybody.
This is Graham over here.
This is Ashkahn.
Kind of jumping on my intro
Well,
there.
you got to go faster.
All right, what I was going to say is today's question. I can't go faster.
Yeah, you just bring it on back.
Today's question for all you listeners is the NAFTS says, by the way, that stands for North American Float Tank Standard. We are unaware.
Did they write it as an abbreviation in there?
Yeah, they did write it as an abbreviation. Yeah. Anyway, it says that we are unaware of any testing device that will accurately measure pH in the float solution. End of quotes. And then the rest of the question is, however, float tank owners claim to be adjusting pH levels, and at least one float tank company sells pH plus and pH minus. What gives?
What gives?
Well, it's a little complicated.
Yeah, so... I mean, part of the reason I think you hear...
You can't see, but I'm pulling on my collar right now.
I mean, I think part of the reason you hear inconsistent information about this is because there's probably inconsistent experiences and knowledge and devices.
And we're all just very confused.
Everybody's really confused. Yeah, I mean, so here's what we know, is that we haven't personally found a device that we've had a manufacturer, like a testing device manufacturer, tell us specifically will work accurately in the float tank water with pH. So that's kind of what we're like. I don't have that hard confirmation, like a letter from someone who makes the testing device saying they tested it in their lab and they can confirm that we are in fact getting an accurate pH with the device.
And there may be manufacturers out there who have had conversations like that or trying to work towards it, and it's just that we haven't necessarily seen that or had personal experience with them.
Yeah, so I don't know. Some manufacturers, maybe they have figured this out. Maybe other ones haven't and just think they have. Like, I don't know. Like, it's hard to say exactly if someone's claiming they figured it out, what lengths they've gone to actually confirm that. But that's usually the lengths that I like to go to. I like to get the actual manufacturer of the device to have tested it and, like, on an official state, you know, like with their company letterhead or something, kind of officially saying, like, yeah, we're standing behind this.
And this is a funny differentiation that's not exactly related to the question, but make sure to get the technical department on the line when you're talking to manufacturers of testing devices, because if you end up just on the general line or talking to a salesperson, absolutely, they will pretty much tell you what you want to hear. So having a salesperson tell you, oh, sure, it'll test pH in the float tank water is not the confirmation you want. Again, yeah, official letterhead. Maybe talking to the technical department.
Ideally, yeah, you don't even want the company to just tell you yes. Like, ideally, you want them to, like, take a sample of the Epsom salt water and actually use their pH device and some other thing that they can use to calibrate or make sure that it is correct. And that's really the tough thing when it comes to pH, specifically, is that I think it's kind of hard. Like, how do you know if you're getting an inaccurate pH reading? Because you just have the one pH device that you're using and you get a number out of it. And, like, if that number is right or wrong when you're testing it in your float center is not something that you can really determine. So some of the reasons that we have suspicion that pH can be kind of maybe inaccurate because of the salt water is, one, as we switch pH devices in our center, they give us very different results from one another.
Yep.
And the devices seem to be consistent with themselves.
Yeah, so the readings that we have are very much consistent, and the thing that we're worried about is validity, right? And the improper readings could be one of the two, right? You could use the same testing equipment, and it's shooting back 6.8 this time, and 7.8 this time, and 8.9 this time, and it's all the same water. That would be very inconsistent. But that's not necessarily what we're seeing. You know, if you take a reading of the pH and it's 6.8, and you take another one, chances are it's going to be 6.8 again if you're just taking it five minutes later, you know, or in that range.
Yeah. And if you put pH plus in, it's most likely going to go up. And if you put pH minus in, that number is going to go down. But the question is, like, is that number right in the first place?
Right. Yeah, when we're getting 6.8, for example, how do we know that wasn't 7.5? And the next time, although we're getting 6.8, it's still at that 7.5 level. Yeah,
so that's one thing that's been suspicious to us, is we bought, like, a different pH tester, and all of a sudden our levels were very different once we were testing with that different device. The other thing that gives me some suspicion is when we did that test with the NSF, the study of just distilled water versus Epsom salt water, they took kind of some basic testing levels on their test. And so basically they took distilled water and they measured things, and one of the things they measured was pH. And then they added Epsom salt to that water and remeasured everything. And theoretically that should have been the only difference. And the pH jumped quite a bit between those two, the distilled water and the Epsom salt water. And so that raises a few questions, right? There could be a couple possibilities as to why that's different. One, I guess they just started with different pH water for those two samples, but I kind of doubt that's what happened. I think they were probably using water that was very consistent with itself.
They could have just lied and thrown darts at a board and never actually tested anything, but yeah, I don't think that's likely either. So
really the two big possibilities is that the Epsom salt itself is actually affecting the pH, right? So at the point that they added the Epsom salt in, that was what was changing the pH of the water.
And you'd put that over some kind of alien mind control conspiracy?
All right, like 2.5 possibilities. And I don't know, like from talking to Epsom salt manufacturers, it doesn't at least seem like the Epsom salt should be making a big impact on pH. That's what they told us. Maybe that differs from manufacturer to manufacturer. That was what PQ told us.
Yeah, at least from PQ, they said that their Epsom salt is actually chemically composed to be neutral.
Yeah.
So it's actually supposed to be at 7 pH. So
right.
If you're adding in the PQ salt, it shouldn't actually affect the pH levels,
theoretically. If you're lower, I mean, it'll get it closer to 7, I guess.
Right.
Not that I want to affect it.
Yeah, that's a good point, for sure.
And so the other possibility, if the salt's not affecting it, the other possibility is that the reader is not giving you the same result that it was beforehand, right? So that's kind of the two different steps of logic. And we weren't really able to get a clear answer from the NSF about that. And I kind of came out of it with them, or like with me understanding that they didn't think their pH was the most accurate thing in the world.
And that they didn't want to give us an
water.
official statement that said that, right? Like they kind of don't want to admit that their tests aren't necessarily up to measuring things in our salt water. So anyway, they kind of did their own pulling of collars, I feel like, when we were having that conversation.
I feel like they alluded also to the fact that they probably could get a much more accurate pH reading with some like much more expensive and sophisticated equipment. So I don't think it's like out of the realm of possibility, but it does make me it makes me question just like getting any old pH reader and trusting it without actually very much validating with the company that makes that it is in fact not being influenced by the salt that's in the water.
Yeah, pretty much anything off the shelf I'd be highly skeptical of. I mean, I certainly don't know of anything unmodified that you can just buy from a testing website or a testing manufacturer that I personally would have confidence works to get accurate pH in the salt solution. That includes test strips, digital readers, refractometer kind of readers. Like, I don't think any of them are just shooting back the accurate levels that we have.
Uh-huh.
But again, personal opinion, we have heard from other people in the industry, especially manufacturers who are the ones who have done really deep research into this area, that they do feel more confident than we do in pH readings.
Right, but
that might be through modifications or customization or...
Yeah. I'd be... to me, I'm really searching for that actual, like, verification from the company. So, hopefully, maybe someone out there has that and we just haven't seen it.
Yeah. Although I'd like people to send us every single piece of float information that would solve all the mysteries I personally have. For some reason, people don't just do that by default. So if you're out there and listening to this and you have a letter from a pH testing manufacturer, shoot it over our way. Or alkalinity or anything. Any letter from a manufacturer that says that stuff is tested accurately in the float tanks would be awesome resource to have.
Definitely.
I think that's it.
Yeah. Yeah, that's it.
All right. Any more confounding questions you have? Send them our way as well at floattanksolutions.com/podcast.
I'll talk to you guys tomorrow.
Catch you then.